In the last section, we learned what compound inequalities were and what they look like, but now in this section, we're going to actually solve them and then get into the graphing and things like we just learned how to do. Okay, so here we go. Wow, these look pretty crazy, don't they? All right, here we go. First thing you need to do is solve both sides separately. So you have this side or this side, okay? Or is like in the last video, this is going to be a union or a disjunction, and we'll talk about that when we get to the actual answer. Okay, but for right now, let's just solve both sides. Okay, so, oh, don't know what that was. Here we go. We're going to add 2 to both sides, and we get 3x is less than negative 12. Divide both sides by 3, and we get x is less than negative 4. Didn't have to switch any signs because we didn't multiply or divide by a negative, nor did we flip the inequality around. Other part, we're going to add 1 to both sides. So these cancel. We end up with 4x is greater than or equal to 8. Now we want to get rid of the coefficient, so divide both sides by 4, and x is greater than or equal to 2. Okay, this or needs to come down as part of your answer. It can be capital or lowercase, it doesn't matter. But this is your solved portion, okay? And it needs the or in between. That's part of it. Okay, now the graph portion, this is what we did in the last section. It's already solved now, so now we just need to graph it. Okay, so here's a negative 4, here's a 2. The negative 4 portion is going to have an open circle. It's going to go to the left. The 2 portion is going to be a closed circle and goes to the right. Or, if you remember, means everything in both. So we're just going to bring those both down onto the graph. So this part will come down and this part will come down. It's everything in both. Technical problems there, I apologize. Okay, so it's this part and this part. Okay, so that's the graph portion. Now we need to write it in interval notation. So we're coming at the graph from the left, just like you read. Okay, so we're going to basically read the graph. First thing we come to is the arrow, which means negative infinity. It points to the negative side. And negative infinity, positive infinity are always parentheses. Okay, and then that section of the graph ends at negative 4. It's an open circle because this is an open circle. Sorry, it's an open parenthesis basically because this is an open circle. And this is open because this does not have the equal to line. This one does. So it's filled in. And when we write it down here, it's going to be a bracket, a closed side. And then it goes to positive infinity and it's open. Because it's a union, we're going to write the U right there. Okay, so this is interval notation. This is your number line. So we have these 3 portions that you need for your answer. Okay, so the only thing different, okay, this is kind of a mess. Let me clean it up. Hang on. Okay, the only thing different between this section and the last section is you have to solve it first. Once you get it to here, you already know how to do it. Okay, so see what you can do on your problem. Okay, solve both sides first and then graph your answers. Pause it and come back. Okay, I'm going to zoom in on this side and On this first part, let's get 2x on this side with the 8x. Now remember, we're going to always move the variable to the left when we're doing inequalities so that it makes life easier for you. If you remember at the end, we're going to use the inequality as an arrow to tell which way to graph. Okay, so we've already subtracted 1 to both sides. So we get 6x is greater than 18. Divide by 6, and x is greater than 3. Okay, leave that one alone. Let's do the other side. I'm going to bring the variable to the left, even though it means making the coefficient negative. I just like doing it that way. You can take it to the right, but make certain that at the very end, you have your variable on the left. You're going to have to switch the sides. Okay, all right, let's get the extras on the other side. So the 2's cancel. Negative 4x is greater than negative 8. Divide by negative 4, and x, flip the inequality around because we divided by a negative, is less than 2. Put our or in between here, and that is your final answer for the solved portion. Okay, put it on a number 9. Make certain you leave yourself space up here to show your work. Okay, 2 is our smallest number, 3 is the bigger number. Okay, so the 3 portion is going to be an open circle at 3 going to the right, because that's how this arrow points, right? And the 2 portion, the pink side, is going to be an open circle at 2 and points to the left. Because it's an or, we're going to take both of those down onto the number line, because or means everything, right? Okay, so open circle here goes to the left, open circle here goes to the right. Make certain that your graph is your final answer directly on your number line. Anything floating up here in the top is considered your scratch work, and it won't count as an answer, okay? Needs to be directly on it. Okay, I'm going to do the interval notation. There you go. Almost called it the wrong thing. So negative infinity to positive 2, parentheses on both. We want the U symbol, union, and open at 3, comma, positive infinity, comma, comma, parentheses. Gah. All right. Let's take a look at the next one. Okay, these two are both and problems. That's going to change things a little bit. You're going to start solving all of this and solving all of this, get your answer, and then graph your answer using and instead of or. Okay, so the first part is pretty much the same. Same thing here. Solve it, and comes down. Number line, and that's going to be and instead of or. Okay, let's get to that point, and then I'll explain and or one more time. So first side, we're going to distribute here and here. So we get 6x minus 12 is less than 6. I'm going to get the extras over on the other side. So it leaves me my x term, and then divide by the coefficient, and we get x is less than 3. Okay, other side. We have variables on both sides, so I'm going to get them on one side. and I get a kick out of this problem because there's no reason why they should have written 0 right here. If you add 0 to anything, it's just what you started with, right? 0 is extra. Okay, so we have a 0 right there. All right, next we're going to add 3. Those cancel. We get negative 3x is less than or equal to 3. Divide by negative 3. That should be a flag because we're dividing by a negative. Flip it over, and there we go. This and has to come down as part of your answer. If you don't put it in part of your answer, then you don't know how to graph it. Okay, that is the rule toward the next step on how to graph those two parts. Okay, actually, let me center that a little bit better on our answer. Okay, we have a negative 1 and a positive 3. Okay, at 3, the blue part, it's an open circle, and follow the arrow right there. It's to the left. Okay, pink part is a closed circle, and again, follow the arrow. It points to the right. And if you remember, and means overlap. Okay, overlap. Yeah, let's try that again. Overlap. Okay, so where do the two of them overlap? It's going to be right in here, right? If I drop the blue line down on top of the pink line, that's where they're going to overlap, is right here. Over here doesn't count because there's no pink part here. And over here doesn't count because there's no blue part. Okay, so when we drop that down, it's basically closed circle at the pink one, open circle at the blue one, and everything in between. So you use the endpoints that you have in the problem, separate sides, and then you just pull it down onto the number line. Okay, let me give myself a little more space down here. Okay, so closed. This is a closed bracket, closed circle, and it's closed because of this equal to. Okay, so this is the pink side, which is this one, which is this one, which is this one. Okay, so that's negative 1, and it goes to 3. 3 is open circle, so this is going to be a parenthesis. And there's our 3 parts. So we've solved it, we've graphed it, and we've done interval notation. Okay, remember, once again, the graph has to be right on top of your line. It's not floating above it. It's right on top of it. Don't get any weird ideas on how you're going to make it look better or change it because you like it better. This is how it has to happen. Okay? All right, next one. This one's yours. See what you can do with it. Okay? Pause it, do it, and come back. Okay, I'm going to zoom in on yours now. And left side, I'm going to move the variable to the left. We end up with 9x add 3 less than or equal to 12. I'm going to move the extras to the other side. We get 9x is less than or equal to 9. Divide by 9 now, so we get x is less than or equal to 1. Okay, right-hand side. I'm going to get the variable over to one side. So I always take it to the left. Whoops. When there's inequalities, I just have it. I go to the left. Negative 3 minus 4x is less than or equal to, 12x's are gone, So that subtract 3 now becomes a negative 3. You have to bring the negative, this symbol down in front of it, so it becomes negative. Okay? Now let's move the extras over to the other side. These cancel, so I get negative 4x is less than or equal to, and these technically cancel too. However, you can't leave this blank. It needs a number because that's the only thing left on this side. So negative 3 add 3 is 0. Okay, now we're going to divide by negative 4, the coefficient of the variable. Because it's divide, and it's negative, we're going to flip the inequality around. So x is greater than or equal to 0, and I have an and in here. Okay, this one didn't quite do what I was hoping it would do, but if you notice, my lines aren't exactly even. Like this one is up higher than that one, whatever. Okay, sometimes you'll have an extra step over here, and your answer is clear down here with this answer here, this answer here. If that's the case, just write your and in between them and circle like that. You know what I mean? I'm not going to be that picky, but you do need the and in the answer. That I will be picky on. Okay, back to here. Let's do our number line next. Make certain you leave room for your work above it. So here's 0, here's 1. Okay, so the blue part. Closed circle at 1, and it goes to the left. Pink part. Closed circle at 0, and it goes to the right. And means overlap. So we're going to mark everything from here to here because everything in here overlaps, right? So our actual graph, you keep the endpoints that you see, and it's going to be in between. So this time, both sides are brackets because they're both filled in circles. And that's your answers. Okay? You don't have to circle this line. Sometimes it's nice because you can find it, but you have to have the word in between. Because if you don't, then you don't know how to graph it. That's your rule of telling you whether you want everything or whether you want the overlap. Okay? All right, next one. And you can see these are getting a little bit trickier. You got some parentheses thrown in. And this says try these. So try them on your own and then come back. But this one is an or and this was an and. So be careful. You're going to graph them a little bit differently at the end. Okay, so pause it and come back. And here's number 3. Okay, so we're going to do each side separately like we've been doing. Variables are already on one side, so all I want to do is get rid of the extras first. So add 2 to both sides. Because I have a negative 4 I'm dividing by, I'm going to flip my inequality sign around. So x is now less than or equal to positive 1. Okay, on the right, we're going to distribute first. So we get 2x minus 2 is less than 6. Add 2 to both sides. These cancel. We get 2x is less than 8. Divide by 2. And x is less than 4. This is like I was talking about on the previous screen where your answers are on different levels. This one's up here, this one's down here. So all you have to do is put your or in between them. You don't need to write them on the same level. You don't need to rewrite it, but if your OCD is making you do that, then go ahead. Okay? All right, next. Number line. 1 is first, 4 is to the right. Okay, so 1 is a closed circle to the left. The pink one is an open circle at 4 and also to the left. Okay, you got this far and then you got lost. Good for you. You got that far at least. All right. Remember, or means everything in both. Okay, however, the blue one overlaps the pink one, right? So if I were to take the blue one and put it on top of the pink one, it basically disappears because it's already included in that pink line. Now remember, the endpoints, that big blue dot, isn't really a great big blue dot. It's just the same size as the line, but we have to draw it bigger so that we can see it. Okay, so basically it's gone. It's sucked into the pink line. Okay, so we don't really need the blue one. We just need the pink one, because I'm going to make that a little bit better to see. Here we go, open circle and to the left, because from 1 and to the left is already covered. There's 1 and to the left. Okay, so the answer is negative infinity to positive 4, open circle or open parenthesis at negative infinity, and an open parenthesis at positive 4. Okay, hopefully you got it without that last part throwing you, but that was a little difficult. Let's take a look at number 4. Okay, if you haven't already done it, pause it and go do it, but I'm going to do it right now. Okay, so we have subtract 3 from both sides on the left. We get negative 1x is greater than 4. And again, you don't need the 1, so I'm kind of laughing to myself about this one, but that's okay. You wouldn't see it written hardly ever. That's why I'm laughing. Oops, sorry. So x is less than or equal to negative 4. We switched it because I divided by a negative, so that needed to flip right here. Okay, other side. Distribute. We get 2x minus 4 less than or equal to 4. We're going to add 2 to both sides. 2, what am I doing? Add 4 to both sides. In my head, I'd already solved it, so I apologize. 2x is less than or equal to 8. And apparently my brain didn't even solve it right. Okay, divide by 2. Whoops. Divide by 2, divide by 2. Those cancel. And x is less than or equal to 4 with an and in between. Okay, number 9. We have a negative 4 and a positive 4. Blue part. At negative 4, it's an open circle and going to the right. Pink part. Closed circle and going to the right. Okay, so looking at these two graphs, they are quite similar. That open and closed dots are in a different place, but that's still, they're both going in the same direction, which makes it a little unique. Okay, and, however, does not mean everything, and means where they overlap. Okay, so see if I can do it with it big and not zoomed in so that you can still see everything. Okay, so I'm going to take that blue line, drop it. Oh, no, I'm not. Apparently, I'm going to twist it. Okay, blue line right on top of the pink one. And because we want where they overlap, okay, I am going to zoom in now. What's happening right here? Okay, over here it's only pink, right? There's no overlap. Right here, however, can you see that this straight line, the pink line, is not overlapping with the blue line anywhere because that's an open circle. Okay, I know that gets a little weird. Okay, so here's the blue line again. And when I drop it down here, I'm just going to go close, but not quite. All of this is overlapped. This doesn't exist. That's why it's an open circle. So there's nothing here to overlap with this pink line right there. Okay, so we're going to put that end point of an open circle, and we're going to include all of this stuff because that's both pink and blue. This is only pink, so it does not come down. This needs to be both colors. Okay, maybe we could use that word. Maybe that would help you, is both. I don't know. Okay, all right, back to here. Our interval notation is negative infinity to -4 and an open circle. Open parenthesis for the open circle. There you go. Okay, so those answers are very similar and the problems are very similar. Once we get to the answer, you have to look at it differently. Everything we want both colors. That's why I don't like using the word both. Both colors, so all of it, all of the pink one as well as the blue one. And over here, it's where both colors overlap. So it is the purple part, like I did before. All right, let's check the next one out. Okay, these are also try these section. So we have an and an or. So watch those carefully. Try both of these, see how you do on them, and then come back. All right, here's number 5. So we're going to do the left-hand side and the right-hand side separately. So subtract 2 from both sides because those are the extras, and we end up with 2x is greater than or equal to 4. Divide by the coefficient to get x all by itself, and we get x is greater than or equal to 2. Okay, other side. We're going to subtract 5x from both sides, get the variable over on the left. So we get 4x minus 7 is less than -3. Add 7 to both sides, and we get 4x is less than 4. No flipping inequality signs on this one at all. So the 4's cancel, and we get x is less than 1. Okay, so far, every time the longer one has been on the right. That's just how these problems are written. It could be either direction. The longer one could be down here. X greater than 2 could be here, and x minus, or x is less than 1 could it be up here. Doesn't matter. Just the bottom line of each is your answer with the word between it. Okay? Circle it if you want, whatever. Okay, number line time. Now remember to leave yourself space above it. So we have a +1 comes first, +2 comes second. Okay, blue part. Closed at 2 and going to the right. Pink part. Open at 1 and going to the left. Okay, you might be thinking to yourself, or maybe you already did, oh, I'm just going to bring that down and bring that down. That would be wrong because this is an and we want where they overlap. They don't. Okay, so if you were to stop right here and move on to your next problem, I would think you got stuck and you didn't know how to answer it. Okay, so make certain that you continue right interval notation. You can't graph it. There is no graph because there is no overlap. However, doing this part, and this part, that's your work showing me that you know what you're doing. And now this is also your work showing me that you know what you're doing, or your answer rather. No solution. Okay? You could also write DNE for does not exist, or no solution that way. I don't care which one you write, just as long as you write something that tells me you left the number line blank on purpose because there was no answer. Okay? All right, let's take a look at your number 6. So for the blue part, we're going to distribute, and we get 8x minus 8 add 9 is less than negative 23. Combine like terms right here, and we end up with 8x add 1. Oh, I'm going to make that look better. Add 1 is less than negative 22. Subtract 1. Geez, my head is doing all kinds of weird things today. I'm sorry. That should be a 23. Now we subtract 1, and we get 8x is less than negative 24. Divide by 8. Because that blue 8 is positive, I don't switch it. Okay? Doesn't matter what the black number is. It doesn't matter what the answer is. If this blue number that I divided on both sides is positive, I don't change this. If it's negative, I do. Okay? Other side. We have variables on both sides. So I'm going to get them on one side. So we get 6x minus 9 is greater than negative 33. Add 9 to both sides. And we get 6x is greater than negative 24. Divide by 6, divide by 6. These cancel. X is now greater than negative 4 because that pink 6 was positive. And I need the or in between. Okay, just a comment while I was thinking about it, while I was working this problem out. Please don't come up with your own way of doing the math problems, okay? If you think you have a shortcut and it makes it easier for you to do it this specific way that you created, don't, okay? I am showing you the way that you need to do this problem, okay, or this problem, because it's correct, because it's mathematically accurate. When you're skipping things, when you're putting things in different places, when you're combining things together in your own method instead of this method, you may not be doing it right. Okay? So, for example, you may not be doing it right. Would your English teacher give you points for that? Absolutely not. Yeah, I know what it says. We can sound it out and we can make it make sense. So I know that this says you may not be doing it right. And if you did something really funky up here and I could make sense out of it, that's great. But you would not get points for this in English. And you would not get points for doing your own method in math either. Okay? Math has its own rules, just like English has its own rules. All right, back to the problem. Here we go. Number line, negative 4 comes first, negative 3 is second. Okay, so the blue part is at negative 3, open and to the left. The pink part is at negative 4, it's open and to the right. Let me make that a little bit better. To the right. There we go. Okay. I have an or this time. So because I have an or, it's everything in both of them. So I want all of the blue one and all of the pink one. Okay. And If I were to take the blue one, put it on top of the pink one, I'm going to zoom in so you can see it. Okay. I want everything, right? So if I'm continuing drawing the line right here, the blue line continues through that open pink dot. Now it's both of them. And now this line continues through the blue dot and keeps going. There is no break in the line whatsoever. Because remember, these big circles are actually not huge circles. They're little microscopic ones that we can't see. We just have to make them big so that we can see what we were doing, right? Okay, so our answer is the entire number line. Okay, trying to make it fill in for you. Everything has a color on it, right? Okay, whether it's blue or pink, everything is included. So it's negative infinity to positive infinity. It's the entire number line. Okay, those are the weird ones. Okay, so the no solution or the all real numbers. Okay, this is all real numbers, yes. However, they didn't ask for the answer this way. They asked for the answer in integral notation. Okay, so that's why I wrote the infinity section instead of the words all real numbers. Okay, so it is, but that's your answer. Okay, so this, where they both are going the same direction, they could also be going to the right, or they could both be going to the left. It doesn't matter, but you need to figure out whether it's everything because it's an or, because it's overlap resulting from the and. Okay, you graph it differently, as you can see. And these as well, they graph differently depending on what you have. Okay, all right, one more thing. Okay, this is a lot of writing. And let me explain what it means. Conjunctions. Conjunctions are and problems. Okay, conjunctions. So, trying to hit the right buttons. Sorry. And problems. Only and problems can be written like this. If you have a three-part, remember we've called them tripartites before, and we looked at them earlier in this chapter. If you have a tripartite, it is automatically an and. Okay? If you're not comfortable doing it as a tripartite, you can separate it. Okay, so notice we have negative 19 is less than x, or 4x minus 3, right there. And then you take the center and repeat it and put the last half. Okay, so the 19 and the center, and then the center with the 7, because this is connected to both. Personally, I won't separate it like this. I will solve it like this if I can. It just saves me time. Okay, and this shows you how to do it, and this shows you how to do it, but I'm going to do it with you on the next page. Okay, so I'll zoom in on ours, but first I want to laugh. Number 3, number 7. I don't know what I was thinking on numbering those. Sorry about that. I tried to fix all of them, and I didn't get them all. Someday I'll write my own notes. And okay, here we go. Because this is a tripartite, I can solve it at the same time all at once. Okay, look in the center because that's where your variable is. If I were to not have one side or the other, so for example, if this side was just not there, how would I solve this? I'd get rid of the extras on both sides, right? It's just now you have another side. So you have to do it at the same time in all three sections. Okay, so it cancels here. We get negative 10 is less than negative 5x, which is less than 20. Okay, you cannot do just two parts at once. You have to do all three. Okay, have to every time. Okay, so we're still looking in the middle. We want to get x by itself. I want to get rid of this times by -5. So I'm going to divide by -5. If I do it on one, like the purple stuff says, you have to do it on all three. So this cancels. I get x. Over on this side, two negatives give me a positive, and it's a 2. On this side, positive divided by a negative is a negative. Because I divided by a negative, I have to flip every one of the signs. Okay, so between these two, I flip that one, like this, right? You flip that one, and you flip that one. Right where they are, just flip them. And in class, once we talked about this, that you have to reverse these as well, so that everything works out correctly. In tripartite specifically, you should have the smallest number first and the largest number second. Okay, I'm waiting on the signs to show you. Okay, this was a positive, this was a negative. This is bigger than this. These two numbers need to follow your number line. Okay, so -4 comes first, +2 comes second, so they need to go in that order. They can't switch. Can't go like this one goes here and this one goes here. That's a no-no. Okay, back to the signs. Notice right here, this sign is pointing to the -4. So when you switch it around, it still has to point to the -4. Okay, and this one, between the 2 and the x, it's pointing to the x. So now it has to point to the x. Okay, so now we have it so it matches our number line. This one's here, this one's here. Tripartites are simple to graph. Because it's a tripartite, it will graph directly with what you see. Okay? Between the x and the 4 is not equal to, so it's open. Between the x and the 2, it is equal to, so it's closed. Because x is between these two, your graph is between these two. Look how easy that is. -4, 2, open at 4, closed at 2. Okay, not every and inequality can be written as a tripartite, but the ones that can will always graph like this. Okay, the ones that can be written as tripartites, this has to be the same on both of them. We haven't done one like that yet. Okay. Okay, so that's way smaller than I was expecting. Okay, you try number 7, your turn. Pause it, do it, and then come back. Okay, because it's a tripartite, we're going to do all three at the same time. However, I'm going to show you how to split it up just in case you don't want to. Okay, so the center part is connected to both the 18 and the 22. So when you rewrite it, you have to connect it to both the 18 and the 22. You just rewrite that middle part. Because it's a tripartite, it's an and. And then you can solve both parts separately like we did before, combine them together, and using an and so it's where they overlap. Okay? Okay, I'm going to pull that one down to the bottom and show you after how it works out the same. Okay? All right, well, let's do this as a tripartite. So we're going to subtract 6 in the middle to get x by itself. So now we have to do it to all three sides, all three parts. Okay, so we get negative 24 is less than or equal to 4x, which is less than 16. Got to get rid of that 4 in the middle, so I do it to all all three parts. Okay, so x in the middle. You keep the signs this time because I divided by a positive. So it's negative 6 on one side and positive 4 on the other side. We don't need to flip anything because negative 6 is the lowest number and 4 is also the biggest number. Okay, basically to keep track of this, you should be using less thans in here. Less than or equal to or less than. Okay, because it's a tripartite, there is no work to show on your number line. All you do is this sign goes here, it's closed. This sign goes here, it's open, and you shade in between. Then closed gives you a bracket, and open gives you a parenthesis. You're done. Tripartites are kind of fun, I think. Okay, so now just to show you that it's the same thing. Wow, that's messy. Okay, I'm going to minus 6 here, and we get negative 24 is less than or equal to 4x. Divide by 4. And we get x, it's a positive 4, so you leave it, or leave the inequality sign. However, now I need to flip it, so I need to switch the inequality sign. Okay, on the other side, let's subtract 6 from both. We get 4x is less than 16. Divide by 4. And we get x is less than 4. Okay, I'm going to slide it up a little bit. Okay, I need my and in between because that tells me how to graph it. Need to leave some space because I don't know what the graph looks like. It's two separate parts. Okay, so negative 6 is on the left, positive 4 is on the right. Okay, the blue part, it's closed at negative 6. Use the arrow, so now it goes to the right. Pink part, it's open at 4. Again, use the arrow, so it points to the right. It's an and, so we want where they overlap, which is in here. Okay, so closed, open, in between. This looks exactly like that. Okay, so it doesn't matter which way you do the problem, you will get the same answer if you do it mathematically correct. Okay, it's just, to me, it's much shorter to do a tripartite, do a triple version instead of separate it and then bring it back together. Okay, that is it for this video. So you're solving, graphing, and writing an interval notation. Okay, and I will warn you right now, the most often made mistake is to forget the interval notation. Okay, that's basically a third of the problem, so don't forget that part, okay? Alrighty, good luck. You got this.